Hey, welcome to my session about 5 shiny test types that might improve your application reliability. Before we start, few words about myself. My name is Yoni Goldberg. I'm a software consultant and architect doing backend only, Node.js only. This is my only focus. I work with startup customers, round A startups working at the garage, up to enterprises like Intel, Cisco, Kaltura, Cox Communication, and others. And all the best practices that I learn at the field, I document them at my repo, Node.js best practices. I'll be glad if you pay a visit. So let's get started. What is the problem? What we aim to improve? Why we need 5 new test types? Well, in fact, we spend a lot of effort and time on our testing and building our testing strategy. And we're doing all of this based on 10 years, quite a old, 10 years old model, which is called the testing pyramid. Now, for those of you who are not familiar with it, it basically and simplicity saying that we should focus on unit tests. Those types of tests that are targeting software component like classes, objects, and are working in isolation, like no database, no networks, only focus on a very specific and narrow software component. And on top of that, we should put lesser focus on integration and end-to-end test, those that test the real thing, the real flows with integration, with database, etc. And it kind of strike me as odd that after all the dramatic changes that the software world has gone through in the past 10 years, we still use the same testing model. Before 10 years, where this model was invented, there were almost no cloud, not really microservices, no serverless, of course. And it's interesting how if you still Google today, Python testing, Node.js testing, Java, whatever, most of the Google search result would be unit testing, testing pyramid. Is it really possible that 10 years of software involvement hasn't changed the testing strategy? And also, a lot of things in the testing pyramid didn't work for me. So I went into a journey of learning what the community think about it, what other tools and other models exist. So I start reading, I spent some time on Twitter, and I found indeed that some voices were starting to put doubt whether the testing pyramid is the right approach. It started with some provocative Twitter storms, this one specifically created by the creator of Ruby, which is not a very unit testing friendly language. But as I kept on searching and learning, I noticed that most of the leading voices in the testing industry right now, within 2019, believe that the testing pyramid might not be the right approach for a lot of applications. For example, this guy in this tweet suggests that we should not focus on unit testing. We should focus on integration testing. And why that? Why many of the testing community believe that we should find or adjust the model that we are working on now, the testing pyramid? Well, the first reason is that unit test a very tiny portion of our application, a very small unit. So to test the whole, to get a great coverage of most of our application, we have to write many unit tests, which takes long time and might be a bit tedious. A true story that I faced in one of my projects, we were always deploying code and fear that maybe we broke some old code. We didn't have unit testing during our deployment stage because the business was moving so fast. And at some time, we were given 4 days to write testing. So we said, okay, we chose unit testing, and during the entire 4 days, we just wrote testing. And after these 4 days ended, we had 10% coverage of the system. Only 10% of our entire code base was covered by testing after 4 days. So we started without confidence during deployment, and after those 4 days investment, we ended with no confidence in deployment. And I kept on asking myself, maybe we could do something better. Maybe we could get a very high coverage during those 4 days using other techniques. The second doubt that many have with the testing pyramid is that unit tests assume that if the parts are working fine, then probably the whole is also in a valid, in a good condition. Actually, unit tester would have looked at this image, you see the body parts moving, and might think to themselves, well, everything looks great, right? All the parts are tested. We have 100% test coverage. All the unit tests pass. So probably the entire body is working correctly. Well, as you can see, not necessarily. And as you can see on this diagram, not only unit testing neglects the integration aspect, they also focus on a very specific layer of our application, putting aside, left untested, many other layers. For example, let's see here. This is a typical microservice structure. So we have a client approaching a microservice. Usually we have some kind of API at the front, and then the domain layer, also called the business logic, and then all the database layers and work and queries and ORM, and communication with other microservice. Now, given all these parts, unit tests focus only on a very specific one, only on the business logic. What about all the other layers? Aren't we fear that issues and reliability issues might occur over there? So you might think, okay, but the testing pyramid also suggests that we do end-to-end and integration testing, which can improve all this integration, less of integration test. And I would say that you're right, but end-to-end test and integration comes with an outrageous price. Like, you have to craft over a CI environment or over a developer machine your entire production cluster, which in a modern application might constitute 40 microservices connected with a message queue and 4 type of database, cache, then all the cloud services. If you're using AWS, it might be SQS and SNS and SES, so many moving parts. When the only thing that you want to test is just your microservices, your specific microservice. So I don't think that I would craft my entire production system in 4 days. And it also kept me thinking, maybe there are other more linear, more cost-effective methodologies, and soon we're going to look at some alternative for end-to-end testing. Now, the most significant issue that I have with the testing pyramid is that it is contextless. It assumes that one model can suit all the type of application that we have in the world. And there is such a great variety of applications. We have like data pipeline application, e-commerce sites full with business logic, UI mashup, deep learning, IoT, searching microservices, so many. And can it be that all of this architecture with all this variety deserve one testing strategy? For example, I'm working right now on an IoT application, and it constitutes these layers. We have many sensors, which throws event into our API, which then immediately put all these events in a message queue, Kafka, and the message queue streams all the data into a data warehouse where the user can then make queries and build all their analytics and searches. Now, where exactly would we use here unit testing? We almost have no logic. What can we test here with unit testing? Most of our application is focused on integrations and data stream and databases. Unit tests obviously don't have a part here. So with all these challenges in mind, I went to look into a better model, one that is richer, one that is leaner, better, which is more cost effective. And it took me some time until I found the ideal model. At first, I found this very nice model, which is called the testing trophy, created by Ken Dodds, who is a known influencer in the React community. And it has two new ideas that it brings to the table. The first, at the bottom, it has a static type of checking like linting. And it also put the most of the focus on integration testing and not on unit testing. First, the static type of testing now these days is a great opportunity because you don't have to code any test to get a suite of tools scanning your code and finding issues. And it's not only aesthetic linting issues. Linting these days can find things like improper error handling, security issues, and there are also a lot of static analysis tools that will check your code complexity or whether you are relying on some commercial license. So you get for free tools scanning your code and find things that will eventually be transformed into bugs. So I think it's a great addition to the testing pyramid. And his second idea is that we should focus on integration testing because they simulate the real world scenarios, unlike unit testing. And I kind of found this model really valuable, but I think it falls short on two things. One, it still assumes that one model can fit all type of application in the world. And second, it's still narrowing only on 3-4 type of testing, but there are other dozens of test types. Why not consider them? So I went on searching for my ultimate testing pyramid, and I find quite a few. There were the Spotify pyramid and testing quadrat, which appears in many books and the articles. And all of them are valuable, but they suffer from the same issues that I already covered. Contextless, focused on very type of specific. And then at some day, I found this model. I read it was found in a great blog article that I highly recommend, which is called Testing Microservices the Same Way. You have the name here up on the screen. And this model brings two very innovative ideas to the testing table. First, it brings a very long and rich list of testing types where you as a developers don't have to rely anymore on a very narrow pyramid. Rather, you have a very rich list, and based on your context, on your needs, your problem, your application, you suit the right testing type. We have here shadow testing, mutation testing, contract, unit, etc. We're going to take a look soon at some of these testing types. The second very refreshing idea here is that we have testing phases. We cannot focus anymore only on development, code level type of testing, because at production, there will always be some unpredictable type of issues and chaos that can be tested only in production. And what do I mean? We might try 100% coverage unit testing, all the code functionality will behave amazingly, but once we deploy to production, we might discover hairy things like some version of Safari at some very specific iPad version breaks our JavaScript code, or our cloud storage like AWS S3 folders are very slow because our files were archived, or our database migration failed. There are so many moving parts in a modern backend architecture these days that it's very hard to simulate all of this in a lab. So you have to also test in production, and it offers here a rich set of production style testing. So with this model in mind, with this idea of enriching our testing portfolio, I now want to demonstrate 5 test tools that are not very familiar, but I think that are the best candidate to enrich your portfolio and make your application more reliable and also linear. The first one in our portfolio is component testing. I would say this is the less innovative one, but I would bet it will be the most useful for you. It comes to address the issue where unit tests are just too small. They cover such a tiny portion of our application, also sometimes unrealistically. And on the other end, end-to-end tests are so big and test so many things that are not our business. So the solution, a balanced approach, it sits in the middle, and it tests our microservice. Our focus should be on testing only our microservice. Practically, it dictates that we should approach our API, our microservice API, and test all the layers of our microservices, database, business logic, everything, not mocking the real one. Only one exception, everything that goes outside of our microservices should be faked or mocked. Okay, so we focus only on the microservice. And I really value this approach because first you test what you deliver. Means you are now your test focus on the things that you are going to deploy tomorrow morning. No more focus on checking how 40 microservices interact together. No focus on a specific function. Rather, you think as a user who approaches your API and you test from this perspective. To achieve this, you test the real internal resources, but you stub the external. If you approach other microservice, you stub it. We're going to see to have a look at the code example. And if you do this, it will give you a much better confidence because you test the real flow that your user is going through. Everything that you're using is going through in your microservices. It is tested using the real world, real components that will be in production. And it is doing so with less I/O. We don't test external things, so we get much better testing performance. Let's see now a code example. So the first part, which is mandatory in component testing, is to stub the externals. Meaning, I'll give you maybe a few seconds to have a look at the code, internalize it. It's a typical unit test written with Jest or Mocha or whatever is your favorite test runner. Now, okay, so the first part, which is mandatory, as I said, is stubbing the externals. Our microservice, let's imagine an order microservice, it depends on a product microservice. So we don't want during the test to approach the real product microservice and instantiate the real product microservice, which is slower and much more cumbersome. So we are using the library, I'm highlighting it now, which is called Knock. You can use any other library. that will intercept the calls to the product microservice and will return some set of data, what depends on what we want to test. Okay? But what will happen under the hood is that there's not going to be other microservice involved, no I/O. Rather, we stub external calls. Now, the second part, which is not mandatory, but I highly recommend considering it, is that we can also boost the internals. It means we can reduce some I/O that will boost our performance. What do I mean? Let's take a look at this. Here I'm instantiating Express. And as you can see here in the bottom, I'm using SuperTest, a library for API testing, to test my microservice API. But SuperTest is able to do this in process. It is not really making HTTP API calls through all the networking layers and outside of process. Rather it invokes the Express routes in process. So you get a much better performance, and you can also get code coverage, and you can also stub various classes because everything is in process. Now, my second tip is consider also changing only during the test your database to an in-memory database. For example, if you're using Mongo has an in-memory configuration, or if you're using SQLize or any other ORM, you can switch to SQLite, which is in-memory. So you get, even your database work is being done in memory, and you get an amazing performance. Yes, you sacrifice a little bit the reliability because you use a different database, but all your data access code remains the same. Okay, so next in our portfolio is the consumer-driven contracts, one of the most emerging techniques that becomes quite popular, and it aims to fit in where component testing falls short. And it's all these scenarios where you have tested your microservice, it works great, but now you have to interact with external collaborators, like you have people using your API or you're using others' API. And there is all these situations where suddenly you change some field or method name and your API breaks, and then your customer complains, hey, what happened to the API? One story that I faced in a project recently, where a user of our API complained that we returned the wrong error. So I asked him, why is it wrong? We documented the error in our Swagger, in the API documentation. And then he said, yes, but I didn't know that if I give this specific input, I will get that specific error. And he's kind of right, because API documentation are static. They might state what theoretically might be returned from our API, but not what get returned based on specific input. So consumer-driven contracts come to automate and formulate all the API contracts and workflow with our users. Now let's see how it is working. This is a high-level structure of the flow, and let me walk you through how you typically test and work with your API users. So at first we have here on the left side the consumer of our API. It might be other microservice or a native application, front-end, anything. And the interesting part is that the testing are defined first on the consumer side. Unlike how we work today, usually the API provider is the one who codes his own test. Here it's counterintuitive. The consumer at first define its expectation. It's a JSON file which states that when we approach any route, what is the expected result or maybe error? Okay? So the consumer might craft these JSON files manually, but typically there are tools that will allow the team to create a mock server and we can generate these JSONs automatically based on the mock server responses. And once we have these expectation files, the consumer have to store them in some broker. Now, what is a broker? It can be any external source that can be shared by the consumer and the provider. Might be a S3 folder, email, whatever. But usually we use some very specific Docker container that act as a broker that know to get consumer-driven contract files. So why we need a broker? So the provider, the API provider, can read the expectation files, the JSON file from the broker, and verify them. And what do I mean by verify them? The provider will have to take all the expectation and play them against its own API. If it is defined that given some route we expect some answer, it will try to approach himself, the API, and see that indeed the expectation is met. If we approach this API, we get back the right result. So it's an interesting flow starting from the consumer who is stating his expectation up to the provider through the broker. And as we can see on the diagram, the production is intact. Nothing changes in production. The aim is to discover discrepancies, misunderstandings in development time. Now let's see some code examples. So we start with the consumer. And is this maybe one word about the implementation? We're going to use some framework here in the example, which is called PACT, a very popular framework which implements consumer-driven contracts. It exists for almost any language like Java, Node, Python, Ruby, etc. And at first, the consumer states its expectations in PACT files. Now, PACT files are just JSON that looks like this. The consumer states that for a given API pass, you see here, it would expect for this type of response, these fields, this type of data, these headers. And as I said already, this JSON file not necessarily have to be crafted manually. PACT framework give you an easy way to create some mock framework that responds, and then the PACT framework also record the responses and saves them in PACT files. Now, at this point, the consumer have to store the JSON files, the expectation files, in a broker. So usually in the CI or maybe manually by running some command, PACT frameworks allow to take all these files and store them outside in a broker. So in the next step, as we can see here, the provider will read these PACT files, the expectations, and replay them against itself to verify that all the expectations are met. Let's go over the code. Note that anything but line 11 is just configuration. What we have here is a typical test written in any testing, under any testing runner. And at first, the provider states here, where are the expectation files, the PACT files? Based on that, the PACT framework here on line 11, when we write new verifier, PACT verifier.verify provider, it will go and fetch all these JSON files and play all the expectation against the API. If it gets true, it means that all the routes were returning as declared in the expectation, meaning our API is fully aligned with our customer expectation. This is how a typical PACT broker look like. It has a UI, and as you can see here, you can see for all of your integrations, consumer, provider, what is the status, when was it modified? So you can get off a high level online automatic view of the validity of all of your integrations. Where consumer-driven contracts fits our strategy? I would say they can complement or maybe even replace partially end-to-end testing, because they allow to test that not only our units are working right, also the interaction between the units are also very much aligned and under agreement between all the components. They are obviously not as good as end-to-end testing, but they are much quicker to create and run. So at some scenario, you might consider them also as an alternative for end-to-end testing. Next in our portfolio is property-based testing, maybe the lesser known technique, very interesting one, and it comes to help us solve the reality where typically we test our code using a very specific samples of inputs, but we fell short to test with production, with the richness and the variety of type of input that our code might be faced with. Let's see this. Let's go over this with a code example. Here we have a function, very simple one, calculate price. It gets 3 parameters. User type is a string, product price is a number, is on sale is a boolean. And we have a unit test that is testing this function. And as you can see, it is calling it with a very specific string, very specific number, very specific boolean value. And it's only one sample of input. So we might code 3 or 5 unit tests with different inputs, but usually that's it. What about all the other combinations of parameters that might in reality get into our function? We might get a very long string with a negative number and some true boolean, or it might be a null string with 0, so many combinations. And usually in production, many times this what will bring our process down. That one weird string that crashed our database because our database field is too short, or that long string that takes our regular expression down because it just takes too slow to process all this string. So many inputs, so many combinations. This is where property-based testing fits in. It aims to give you a very simple approach to invoke your function with hundreds or thousands combinations of inputs. Let's have a look at a code example. So we have the same function that we want to test here, the same calculate price. But now we're going to invoke it with a library which is called testcheck. Testcheck is a property-based testing style library. And you can see with 3 lines of code, I can first tell testcheck what type of parameters my function expect for. And then it will execute it. But it will execute it with 100 or 1,000, based on my definition, combinations of input. As you can see downstairs, the console shows you the function input. And there is a very rich combination of values feeding into my method. Now, knowing that your unit test passes, given 5 types of input, if this gives you confidence, consider how confident you feel knowing that your unit test passes under 1,000 types of inputs. It's very valuable tools to increase your testing confidence. Now, what we see here is not a unit test, it's just an invocation of the method. Let me now show you how a property-based testing might look under a test suite. So no matter whether you're testing with Jest, Mocha, Ava, Tap, whatever, you have to search for a property-based test libraries that suit your testing runner. In this example, I'm using Jasmine because I'm running my test with Jest, but you have also libraries for Mocha and all the others that I mentioned. Now, as you can see here, I have a unit, I have a test, and first I'm stating my parameter types, and I'm invoking the function here, but I'm not passing, like in unit test, specific sample, specific data. Rather, I let the property-based testing library generate the input for me. And it will generate maybe 1,000 type of permutations. So the unit test will run only once. This unit test will run only once. But within this run, it will invoke the function how many amount of iteration that I choose. If one of them will fail, the test will fail. So it's very valuable to stretch my testing capability. But can you spot a serious issue here? It might strike you as odd that I have here an expectation for a result, but how can I state my result expectation if I didn't set any input? Usually you know what answer to expect for because you provided a very specific input. But this time we are creating dynamic, randomized, multiple type of input. How can we know what will we get in return? So it's very challenging to set the expectation when running 1,000 permutations of your function. And indeed, this is one of the caveat challenging part of property-based testing, but it's also the interesting and unique strength of property-based testing. Now let me explain where this technique might turn valuable. At first, although you cannot expect for a very specific output, as stated, you can try to generalize your expectation. Now, don't think about what will be the answer from a very specific input. Try to think what will always be the return based on a family of inputs. For example, in my testing here, I might say, I'm going to provide 1,000 type of inputs. I don't know what will be the exact price that I will get, but I assert that it will be always greater than 0. Otherwise, it doesn't make sense. I can also use property-based to assert some general border of health around my application. Like I can say, I'm going to invoke my function 1,000 times. And I would expect some value, I don't know which, some value or a valid error. Valid error is an exception that inherits from JavaScript error object. And given those, I know that my functions broadly behaves correctly. You might be surprised how many times you will invoke a Node.js or JavaScript function, and what you get in return is some kind of weird error or string as an exception, or your process might crash. Anything but a valid error object. Also, property-based can prepare the ground for unit testing. And what I mean by that is that you can first run your function, your test with property-based testing, test all range of inputs, and then you might realize where your functions fail and under which specific types of inputs, and then write your unit test based on that. Write unit test samples for the cases that property-based discovered, cases that seems to fail. So property-based testing is requires some mind shifting, mental shifting. It's not easy to absorb it at first, but I suggest that at least you remember that there is a method that can invoke your function, your test, with a lot of permutations and combinations of input automatically. If you remember this, the next time you're facing a scenario where you might need it, you can dive deeper and investigate the specific libraries. Number 4 in our testing portfolio, mutation-based testing. Maybe the neatest one, and we're going to have a look at the demo soon. And the motivation for mutation-based testing is to improve how we measure the effectiveness of our test. It doesn't come to replace any of the testing pyramid methods, rather to improve our overall test effectiveness measuring. And typically today we measure the test efficiency using coverage. Yes, coverage tells us which area of our application is being reached by our test. And this metric is sometimes a liar. And why do I say that? Let's have a code example. So let me show you now why I think that sometimes coverage might be a liar. So we have here a function, calculate price. You should already be familiar with it by now. And I also write some testing against this function. And you're going to see that when I invoke the test, they all pass successfully with a great coverage, 83%. I should be very confident enough that if someone intentionally intentionally rather unintentionally creating bugs in the code, my testing will reveal this, right? This is, after all, the purpose why testing exists in the first place. So I would just change the code and create very random logic here. And you can surprisingly see that the test keep on passing successfully. How come? How come my successful test didn't reveal that I just created bugs in the code? Well, let's now have a look at the testing file. And as you can see here, the test, as you can see here in line 5, indeed invoke the class and the function, but they don't test anything. They don't assert for any response. And this teaches us that coverage and assertion, like truly checking something, are not the same thing. Even if I create some assertion here, let's check for something. Oh, the test failed now because I changed the code here. Let's revert. Should be fine now. Yeah, the tests are passing again. So even if I put some assertion or expectation in our test, can you easily tell if I didn't miss any logic, any edge case? It's not very easy to always conclude and detect that we are testing all the different paths of a function. I once presented this in a class full of people, and this is only a 4-line code function, and it lasted 5 minutes until everyone realized what is not covered here. This is exactly where mutation-based testing and Striker as a library that implements it can be very helpful. What Striker is doing is exactly what I did manually. It is invoking the test first, ensure they pass, and then it starts creating bugs in the code, like changing lines of code brutally. Striker is calling this type of bug mutation. Anytime it changes your code, it is creating a mutation. Then it is running the test again. If your test fails, it's great. It means that they detected the bug, and it is being referred to as they killed the mutations. But if the test keep on succeeding, this is bad, and Stryker counts this as a mutation that survived. Now, the more mutation survives, the less our code is really covered by testing. Let's see an example of Stryker. So Stryker is really cool because it also need no any to write any type of test, just configure it and point it to our code folder. Then I just click Stryker run, like I'm doing now. And now Stryker in the background is going to start changing my code, planting mutations, running the test all over again. And then it will generate a very nice HTML reports. Let's see. So Stryker here shows me how many mutations were killed and how many survived in the code. So of course, obviously, my goal is to kill all the mutation, or at least most of them. And whenever a mutation survives, Stryker can highlight here in the code what exactly did it change in the code that was not detected by the test. So for example here, Stryker just changed this whole phrase into the expression true, and still all the testing were passing successfully. And this is happening because I just forgot to cover some code paths, so the test didn't fail because of this change. So using this technique, I can realize how much of my code is really covered, is really tested by logic, and manage my reliability and my continuous integration also based on this metric. Number 5 and last in our testing portfolio is chaos testing tools. And I'm going to also show you here a demo of a library that I created. Chaos testing is here to remind us that no matter how good is our code flows, there are external things affecting our code that might make a great deal. And what do I mean by that? Our code might work just perfectly while we might hit memory issues. Our process might get crashed, not because of our code, because some operation system type of issue. If you're using JavaScript, it might be that the event loop might get blocked, and many other type of chaotic type of scenarios. So chaos testing suggests that we cannot really prevent all these bad things happening in our production, but we can at least test in advance how our application is going to behave under all this type of chaos, and we can mitigate and optimize the user experience for a lesser damage possible under these scenarios. For example, the classic scenario is that if our process crash for some reason, our microservice, or rather should I say the user experience, should not get affected, or at least should stay as optimal as possible based on the circumstances. So let's see an example of a type of chaos testing. The traditional classic chaos testing is done by what is called a chaos monkey. A chaos monkey basically just kills servers or processes, so we can ensure that nothing bad happened to the business, to the user, because only one specific server just died. So I'm going to exemplify this with there are chaos monkeys for AWS, for GCP, for many environments. I'm going to demonstrate a Kubernetes type tool, which is called KubeMonkey. So with only a few lines of JSON, which you include in your Kubernetes deployment resources. It will pull a KubeMonkey image container, and then onboard to your application microservice a new friend, the Chaos Monkey, which will periodically, based on a timeline that you can configure, will just kill pods container, and it expects you to, in the meanwhile, test your application, maybe run end-to-end test or let your user work. Then you have to ensure that nothing bad happened because it killed a pod. Now, I think it's a great type of testing, but it is very much focused on out-of-process type of chaos, like network type or operation system type. But what about all the bad things that happens within our process, in our platform? For example, in our process, it might happen that we might have memory leaks, or some other component in our application might throw uncaught exceptions, or in JavaScript world, maybe our event loop get blocked. There are a whole lot of list of bad things that can happen inside our process that we also want to measure and test in advance. So I wrote a GitHub package which is called Node Chaos Monkey that is doing all this type of in-process damage. Let me show you a demo. Okay, so let me now walk you through the in-process Chaos Monkey that I've created. Here it is in GitHub. It is still private. I plan to release it probably sometimes next month. So this is the homepage. And what I want to demonstrate now is how my typical Express API application cope with chaos. In other words, how does my API, which is a very straightforward type of REST API implemented with Express, how well it performs when there is chaos happening within the process, like the memory is being overloaded, the CPU, the event loop, etc. So let's see how we can get this test configured using the Chaos Monkey. I've intentionally designed it to be to minimize the setup as much as possible. So with 3 steps you can get up and running. First, npm install, obviously. Second, run your application. Only include one new phrase, -r require the node Chaos Monkey. This will inject the Chaos Monkey into your process. And now, although you can use the command line or the Chaos Monkey API, probably the most convenient way is to just use the UI. The Chaos Monkey has a dedicated UI and use it. Let's see it. So at first, let me run my application. This is a very typical Express application created with Express generator. Now I should, once it is ready, I should get a UI. Okay, so this is the Chaos Monkey UI. So what we have here, first I can choose here what we call pranks. Pranks are kind of a damage you can do within a process. For example, you can make the API start returning 500 errors, or make the process exit, or throw an uncaught exception, or unhandled promise rejection, overload the memory, the CPU, block the event loop, etc. So you can choose here a specific prank, or you might just choose some plan which will throw multiple type of pranks randomly. And on the right side, you can see your process metrics. So once you're doing your testing, you can see how well your API behaves under the chaos. So at this point, you can just start the chaos and manually test your API. But we also included a tool which allows you to define your API here, or in the future, maybe import a Swagger file. And the Chaos Monkey tool will also create calls against your API and simulate the manual testing, simulate the users really approaching your API. So this is a REST API that I'm using in my application. Now let me choose some chaos. And once I click here start, the Chaos Monkey will start calling my API. On the same time, we'll create multiple type of chaos damage to the process and will show me how in the metrics phase on the right side, how well my API cope with all of that. Let's start. Okay, everything looks fine. You can see on the right side that my API for now is working great. It is serving all the requests. Oh, as you can see, suddenly the API is not alive anymore and the number of errors keeps climbing. Let me check what happened. So I can now look at the pranks log and see what type of chaos might have caused this API downtime. So the event loop was blocked for some time and unquote exception was thrown. I probably have now to go into my logs and try to inspect what happens. At first I can see that the process is down. You see there is no process running. I can learn that my Express API just crashed. It's an important observation, and what led to this crash, I can see that once an uncaught exception was thrown, my process just died. So it's a very important observation for Node.js developer. If a third-party library will throw exception that you don't handle, your entire process might be serving at the same time 2,000 users will go down. By acknowledging this, you can now react thoughtfully. You might monitor this. You might maybe handle the errors or any kind of mitigation phase that you can apply before going to production. So we have seen 5 new shiny testing tools, and maybe by now, like me, you acknowledge that as of 2019, no one can really suggest 3 specific testing tools that suit all the applications in the world. There is such a great variety of architecture types, budget, testing tools, that it must have more context before you build the right mix of tools for your application. We also have seen that the modern tools are a bit leaner. They require less setup to get you up to speed and provide you with value. So given all of that, I believe that if you tailor the right mix of tools for your specific application, you can reach better reliability for better return on investment. And if you want to benefit all of this, you have to start practicing and opening your mind for a new testing tools. We're done for today, but this is not all. There are other testing tools that we haven't covered today, like VCR testing, like database testing, shadow testing, fast testing, and many other. Do you want me to record part 2 of this session? If yes, please let me know in comment. And in overall, your comment means a lot to me. If you can leave anything, a good feedback, critic feedback with some suggestion for improvement. Do you want me to record a complete testing course? I would really appreciate it. If you want to keep following me, you can subscribe to the YouTube channel. You also have my Twitter accounts up on the slide and also my website. Thank you very much.